Hello, this is Ali with Powerline Reporting. Today we're going to take a look at a new PRG feature, the Broken Wire Optimization Report. So inside of the structure setup blade, after loading an XML file, you'll notice a new button, the Broken Wire Check. So if you click this button, it's going to generate this Excel file, the Broken Wire Optimization file. Now this file has three separate worksheets, the broken wire optimization, full, and structural loads criteria. The first and the last worksheet basically contain the same information, but the last sheet is formatted to make it a little bit easier to paste into PLS-CADD. The second worksheet, the full worksheet, is it's going to run through and show you every single combination of broken wires and give you the resulting internal forces, so you can verify that the reported case for every structure is in fact governing. So if we take a look at this sheet, we notice just moving left to right that we were iterating through each structure, every load case that's applied to each structure, and then we're looking at both the back and the headspan wires. And you'll notice for some of these cases, the back and the headspan wires have different number of controlling broken wire cases. So how is PRG determining how many wires to break? Well, if we take a look in the settings under notifications, broken wire notification options, we have at the top two types of broken wire conditions. The first is to define a percentage of broken wires. So you can say, I want to break 1/3 of the wires on the structure in the back or the headspans, and PRG will based on some of the other filtering options, will choose a certain number of wires to break, and then we'll iterate through every single combination of those broken wires, calculating the internal forces, both shear and moment, in the structure, and then iterating through that list, finding the combination that led to the highest internal forces and reporting that in the output report. So that's with the minimum percentage of broken wires selected. You can optionally use just give it a fixed number. So in this case, instead of basing the number of broken wires on a ratio, it's just going to break a number of wires consistently for every structure. So in this case, if you have this selected, and you can set this to whatever you want, but in this case we have it set to 3. So for every single structure, load case, and then side, back, or headspan, it's going to break 3 wires, but every single combination of 3 wires, and then report the single combination that leads to the highest usage. So like I said, this report, these are all of the governing usages, the governing broken wire cases. The second sheet now goes through every single combination. So if we're looking at this first structure, we see under the 60-degree load case, all of the backspan wires. These are each of the separate broken wire conditions PRG ran, with the resulting maximum moment and shear force that resulted from each of the combinations. Now this last worksheet is it's going to have all the same information as this first worksheet, but as I mentioned, it's going to format it in a way that makes it easier to work in PLS-CADD. So if you notice, the column headers and the formatting here matches what you would find in your cable load adjustments. So what you can do, you can copy this information So copy out all of the, starting from this number one wire, number one command, number one value, and come into PLS-CADD. And then if we go into our structure loads and scroll over, so in this case, have a separate load case here for every structure. And these are just going to be used to apply this these broken wire cases. So for each of the structures here, we've added a cable load adjustment, but all of the cable load adjustments are empty. And this is where you would typically go through and define the wires that you want to break, and go manually, apply the value. And so in this case, this would just break one wire, and if you want to break multiple ones, you'd have to continue filling this table out. But since we've generated that information in the this format that's readable by PLS-CADD, we can just come in here and paste that table. So this is just taking what we just calculated to be the governing broken wires for each of the structures, and then pasted that straight into PLS-CADD. So once we've set that up, you can then run a structure check, and I'll just to show that those load cases were applied. Let's come into our summary report, and we'll see. So there's this final load case here that was now is applied to every structure, and it gives us our broken wire condition. Now there are a number of other settings that you can use to help filter and refine the resulting broken wire cases. You can include or exclude certain set numbers, define a voltage that you don't want to, so anything below a certain voltage you can cut out. And then you can also require a certain number of load cases that you want to have, so a certain number of broken wire cases per structure that you have to enforce. So have a number of different options here to help generate this optimization report, which will hopefully help in streamlining the process of choosing broken wires and setting up your PLS-CADD criteria file to account for the broken wire conditions that you need to meet your compliance requirements. So thank you for taking a couple minutes to check out this new feature. Hope you enjoyed it, and I hope you find it useful. This has been Ali with Powerline Reporting, and hope to talk to you soon.